Minna-sama, konnichiwa. Welcome everyone to ARCHICAD 21's worldwide premiere here in Kyoto, Japan. I am sure everyone in this very room, as well as the thousands of people following us online, are very eager to learn about the brand new features coming in ARCHICAD 21. Of course, we will cover those because that's why we are here. But I'm happy to tell you that we will be speaking about a much more important thing. I think something which is much more relevant to your business as well. If you look deep, I guess you will agree with my statement that at the core of your business, your competitive edge, are workflows. So the better workflow wins hands down. That's why we will spend the next 75 minutes speaking about workflows. Actually, 4 of those spanning across the entire AEC process. First, we will cover the conceptual design phase, and we will explain to you how we believe technology can help bridge the gap between concept design and building information modeling. Then we will proceed on to hardcore architecture design in BIM with ARCHICAD 21. And then we will widen the angle and we will speak about how multidisciplinary collaboration can happen in the best of breed way in between different disciplines. We will conclude our today's demonstration with technologies that help spread the usage of BIM across all the stakeholders of our industry. So let's start with the very first workflow, which is about concept to BIM. And here, I think you all agree that algorithmic design is something which is very much quoted these days. And I think the very first thing that you will think about when talking about algorithmic design is organic forms. But I can tell you that we are pretty convinced that algorithmic design can do much more than just form finding. Actually, we have released exactly 1 year ago our Rhino-Grasshopper-ARCHICAD live connection, with which we targeted to build a deep integration between these fundamentally 2 worlds. What it does for architectural practices and the whole industry is allow the BIM processes start much earlier, actually right away when a project is kicked off, and allows the design concept to be kept live and fluid much later on in the process. So this is a very good approach to integrate workflows in our industry. And in the past 12 months, we have done a whole lot of things. Our customers have been doing lots of very interesting, fantastic things. But first, let's talk about our part. So for that, let me invite on stage my colleague, Ákos Karockai.
Thank you. So, as you all know, and as Ákos mentioned, we've been out on the market with this solution for over a year now, but we haven't been resting since. So let me show you some new stuff that we've been working on to further deepen the integration between Grasshopper and ARCHICAD. Also, please note that I'm using the Mac version of Rhino, Grasshopper, and of course the live connection as well. With the latest update to the Grasshopper-ARCHICAD live connection, we implemented another ARCHICAD tool into the Grasshopper toolbox that helps us cover another mission-critical step in a design workflow, that is zoning. So now, with only 1 click, we are able to generate full-fledged native ARCHICAD intelligent zones right away from Grasshopper. But why is it useful for us? It's useful because we can check our building against the different zoning requirements on the fly as the design evolves, and helps us cover the data track. But usually, these buildings have a detailed design program that is allocating the different functions within the building. And of course, the Grasshopper-ARCHICAD live connection can come handy managing this as well. With only a connection of a node, we can fill up our empty generic zones with metadata. For example, zone categories or functions. In our case, this can be parking lots underground, shopping and retail areas, offices, and some residential zones above. And since we are in a native building information model, we have access to the interactive schedule right away, where we can see the metadata that is incorporated in the zones. These can be calculated floor plan areas, volumes, or any other metadata that we would like to extract from the model as well. But what happens when, for example, the client would like to change the program of the building, or even the shape and the form of the building? It is very easy to follow these changes with the help of the Grasshopper-ARCHICAD Live connection. In our case, for example, we can change the numbers that are defining the functions in the building. So let's say the client would like to have 5 penthouse floors on the top of the building. We just change a couple of parameters in the function, in the Grasshopper code logic, and this will automatically synchronize into our building information model. And as you can see, in a blink of an eye, the new penthouse stories appeared in the schedules. But since the schedules themselves are derived from the model, if we change back to the 3D model, we can see the changes right away. Now, this workflow with the zones is a great example for data-driven design. But let's move on from concept to design development, because eventually our goal is to create real construction elements, real BIM elements. So let me just turn off the coloring of these zones. And as you all know, it is very easy and handy to place real BIM elements through the Grasshopper-ARCHICAD Live connection, which in our case can be the parking lot's retaining walls, the structural core shaft of the building, or its smart column grid system, which can adapt to the shape and the form of the building, utilizing Grasshopper's parametric capabilities. And of course, there is no building without slabs. So let's just place a couple of native ARCHICAD slabs by connecting a couple of nodes. But during the design process, we would like to even develop the level of the detail of the construction elements as well. And I could bring up the slab settings dialog, where I could set up the different composites, layers, any metadata that I would like to incorporate into these slab elements. But I don't want to deal with this now manually. But with the help of the favorites of ARCHICAD, with the latest update to the Grasshopper-ARCHICAD Live connection, now we have access to the favorite catalog of ARCHICAD right away from Grasshopper. So instead of using these slab settings and dealing with them manually, one by one, I can just browse through the prepared ARCHICAD favorites, select this detailed slab structure, and just connect a couple of nodes so we can advance and develop the level of the detail of the construction elements themselves. And as you can see, we have these native slabs with all the flooring and the suspended ceiling information. And these elements are later on easily editable, or we can even adjust the parameters or the metadata manually if necessary. And if we were to update the favorite itself, with only one click, we can just simply update the whole BIM model, all elements in one click. Now, besides favorites, besides zones, we added a very new Rhino-like feature to the live connection. That is the bake-through copy. This means that we can break the connection between Grasshopper and the certain ARCHICAD elements, and this way we can visualize different design options, design variations, or even we can walk through the evolution of the design itself. In this case, I used the same Grasshopper logic and just changed a few form factoring parameters, or the number of the stories were changed. And even thousands, 10,000s of elements can be created very easily. And all of these were created with the help of the Grasshopper-ARCHICAD Live connection, of course. And finally, I would like to show you what level of detail can you achieve with only a few hours of work, really. With this very solution. I took this high-rise building of ours, and I continued working with it, added some new construction elements, and developed the level of the detail of the elements as well. I created a detailed curtain wall facade and a parametric shading system, and even the foliage and the terrain was used was created with the help of the live connection. And if we want, we can go into details such as trying out different office layouts within the building to check different design variations here as well. And again, these are all native BIM elements, columns, beams, slabs, and we can work with them later on manually. So far, we've been talking about 3D mostly, but I would like to emphasize that any changes made to the Grasshopper logic will be rippled down into the finest details of the 2D documentation, whether it is a 2D floor plan or a detailed section or elevation. And even if you think back to the beginning of my demo, if we change the same form factors or functional layout parameters of the building, and if we resynchronize the whole thing, then even the 2D documentation information will be updated and will be synchronized. Now, that is what I wanted to show you today. I hope you liked it, and I hope you can see the great potential in this tool. And hope you try it yourselves if you haven't done so far. Thank you very much.
Thank you, Ákos. These were just highlights coming from this development track we are working on. Because in our pipeline, there are exciting stuff like project-level control from the algorithmic design part put up on BIM. Or next, right after that, controlling parametric objects or creating parametric objects from algorithmic design tools. I guess you agree with me that these are all huge potentials for our industry. For now, what I wanted to do to conclude this part of the demo is to play a video of a collection of examples we received from our customers from the past 12 months. I hope you liked it. Now let's proceed on the second workflow we would like to share with you today. This is all about core architectural design in the BIM environment. And here I would like to stop for a minute, because I think we have to realize that BIM in the past two and a half decades was being used for mostly automating the documentation work of the practice. Of course, BIM provided good 3D visual feedback to designers, or you could run certain specific analysis as well, but BIM hasn't contributed very much to core architectural design work. And we believe that BIM should be able to do that. So if we take an example from the architecture design workflow, there are lots of parts of the building that are complex iterative processes. For instance, what you can see on the screen right now is a screen capture from Neufert Architects Data, which is the most popular architecture code book worldwide. In that book, very thick book, a full chapter deals with stairs. In that chapter, 10+ pages deal just with the ergonomics of stairs. What does ergonomics mean? Your stair what you design has to be convenient for the user, for the human, and also it has to be safe so that the people don't fall down and break their necks. So architects have big responsibility to create these code-compliant stairs, and they put lots of energy to achieve that, which means lots of iterations before they can actually input their stair into the BIM environment. Iteration is something computers are pretty good at, so I believe we should explore how BIM could help designing complex structures like stairs. If I want to take an everyday example, Google Maps is a good tool for route planning. If you want to go from A to B, in our example from Kyoto airport to Okura Hotel here in Kyoto, then you give this input. You also define if you want to go by train or car, and the computer, Google's servers, run lots of iterations and try to limit the infinite number of possible routes to 1 or maximum 3 options. And when you get there with a very simple input, you solve a very complex issue. I think stairs are, with a little exaggeration, similar to that. So in a stair situation, you want to connect 2 stories, 2 floors. You want to go from one story to the other, and as I said, you want to make your stair safe, convenient, in other words, compliant. In ARCHICAD 21, after long years of work and innovation, we are very happy to introduce our industry-first predictive design technology that we are seeking patent protection for, which, if I wanted to put it this way, is the very first practical implementation of artificial intelligence, or AI, in any BIM application. To show to you our brand new Stair Tool, Stair Design Tool, I would like to invite on stage Peter Kontz.
Thank you, Ákos. Hello, everyone. Today, I'm very excited to show you our latest innovation in ARCHICAD 21, our brand new stair and railing design solution. As Ákos has promised, creating stairs in ARCHICAD is really easy. So let's see. In my first example, I'd like to connect these 2 slabs with one single stair. It was easy, right? How is that possible? The new stair in ARCHICAD 21 is supported by an intelligent algorithm that helps us create this stair in a very graphical and intuitive way. So, did you see me calculate any steps, any riser heights or thread widths? I didn't do that because we have been able to specify these rules before creating the stairs. These rules can be calibrated easily to any kind of national standards, so potentially you can turn this stair tool into a Japanese, American, German stair maker as well. Now let's see what happens if I know where my stair ends, but I don't know where my stair will start. I can actually create my stair the other way around as well, just going down, adding a landing as well, and easily finish my stair just like that. Now these stairs are also connected to the stories as well. So if I change my story settings, let's say, increase this a little bit, the intelligent algorithm behind the stair will recalculate all the steps automatically, and still within the rules that we have set before. Let's see in another example what happens if I make a slightly bigger change. Now, in case we have specified a change which the algorithm cannot obviously calculate, then ARCHICAD will give us a warning that some of these stairs has to be reviewed. Now, it is pretty easy ARCHICAD will also tell us which part of the algorithm was not able to be met. So we can easily find this parameter, correct it, and the link between the two stories will be restored. Now, this was a very simple example. Not all the situations are so easy. In most of the cases, we have to put our stairs into a very specific context. In this case, I'd like to put my stair between these three walls. Let's see how we can do that. It's very easy. As you can see, I can just start making the stair, and I have a very nice and graphical feedback about the stair being created. Now, in the second segment, I'd like to switch to a landing. I can easily do that on the fly, just changing the flight to a landing and changing it back to a flight. Now, you can see already on my preview, and when I finish my stair, that this actually doesn't fit into the space. Now, do you think I have to make a new one? In fact, I don't. I can simply adjust the steps of these stairs, and the intelligent algorithm will help me to rearrange all of them. Now, we have a different situation here. I'd like to create a stair that fits exactly into this space. So I would like to start from the bottom left corner, going all the way along the wall, and finish on the bottom right corner. Let's start again. As you can see, we have this beautiful graphical preview of how our stair will look like. And I can change easily from flight to landing on the fly. And now we have a preview again, which shows us that this actually doesn't fit exactly to the space. What can we do? Do we have to start again? No, because the intelligent algorithm has some flexibility inside, so I can easily adjust my stair to the final corner, and all of the steps will be recalculated by the algorithm. So we have a very intuitive experience, and the algorithm will help us in the background. In this example, I have a different challenge. I'd like to create a stair with the smallest possible footprint. So I will start from this point and continue, and I'm trying to make my stair from 3 flights of stairs. I don't want to use a landing this time. But when I finish my stair, my preview changes. What does it tell us? This means that given the current design constraints, the stair cannot be, there's no obvious solution to this stair. So in that case, we have a stair solver to help us, which will give us some design options we can choose from. So the decision to choose one of these options is in our hands. We see 4 of these options, but in fact, there has been thousands of options evaluated in the background. So we can see each of these options is highlighting those parts that has been changed according to our initial design. For example, in this case, we have a landing, and in this case, which I think is the most appropriate, the starting point of our stair has been modified on the left side. So I can choose this solution, and voila, I have the smallest stair. In this example, I'm going to demonstrate to you the magic wand. I'm sure all of you already know this amazing productive feature in ARCHICAD, and now it is possible to use that with the Stair tool as well. Let's see how. I can simply use the magic wand on this wall, and will also give me a very nice graphical feedback. Now, in terms of stairs, it is also important to have the appropriate 2D representation as well. Just as easily as we can adjust the 3D view, we can also edit the 2D symbol of the stair. I can easily move these text items. I can easily move the break line or change the position of some of these numbers. So I can flexibly customize my symbol to meet any kind of national standard. You may have noticed before that we have been using this schematic view. It is an option in ARCHICAD 21 for you to be able to view and look at the stair to understand the logic and the structure it has been created. But of course, this schematic view, this always represents a real stair with a very detailed 3D body. Now we have seen how to create new stairs. Let's take a look at how to edit the existing stairs. There are two fundamental ways to edit the stair. The first one is to edit the boundary line. When I click on the stair, you can see it is highlighted with two thick green colors. This is the boundary line of the stair. This, if I change the boundary line, it will change the contour of the stair, which enables me to create really interesting shapes. It is very easy to edit the contour. It is just like editing a slab or a fill. I can easily curve these segments, add new points, customize it to my liking. Now in the second example, you can see that the baseline is highlighted with blue color. If you change the baseline, then the entire structure of the stair has been recalculated by the intelligent algorithm behind it. So we can be sure that the new stair is also compliant with the rules that we have set before, but we don't have to bother with changing all the steps manually. The intelligent algorithm will do that for us. Of course, it is possible to combine these two ways of editing. We can edit the baseline, we can edit the boundary line as well, at the same time creating really, really exciting shapes. Let's see how these stairs look in real life. As you can see in the first case, we didn't really change the structure of the stair, only the contour. And in the second two cases, both stairs have a very different structure because we have edited the baseline. So far, we have seen how to edit stairs in its entirety. Now let's look at editing the sub-elements of the stairs. So the stair in ARCHICAD 21 in assembly element, we can actually go down to the sub-element level and edit individual components, such as these threads. I'd like to make and model this kind of stair, which includes a cabinet and which includes the extension of the bottom 4 threads. And it's very convenient in ARCHICAD. I'm sure you already know we can work in any kind of view. We can conveniently choose the view that we prefer to work with. So in this case, I'm just switching from the 3D view to the floor plan view, as I find it's more convenient to edit this step in the floor plan view. And you can notice that I am still inside the editing mode, so we can switch between these views very easily and still remain on the sub-element level. So all I need to do now is finish up my editing, extend the risers too, and we are almost there. Now that my stair has been finished, all I need to do is connect these stairs with the 2 walls that will make up for the walls of the cabinet. I can easily use the solid element operations. There we go. Stair does look like in the picture, isn't it? Now you could say this was a fairly simple example. Let's put our stair tool to the challenge and see if we can model this stair as well. We can start with a basic stair structure like this, which will give us the basic logic, the heights of each steps and the landings. We can start editing the steps. So it is possible now to convert individual steps into morph elements and create the desired shapes easily by editing the morph. For example, I can extend a little bit in this part, and I can start creating my shapes. Fortunately, I don't have to spend time with doing that now, because I have already prepared the steps for you. So I can just start changing these individual steps to give you an idea how this can be done. So you can see I can go on and change all of these steps, and the result will look like this. Now this is still one single stair. So you can see what kind of extreme and beautiful shapes we can create with the new ARCHICAD Stair Tool. Of course, modeling is not everything about making stairs. They also have to look good and they have to look good in 2D as well. They have to be up to the national standards of architectural documentation. So in this floor plan view, we actually see the same stair that we have seen in 3D with the proper 2D symbol. As you have seen before, we can pretty flexibly edit the 2D symbol as well and create whatever display we would like to see. Now, in such a complex stair, it is really important to create detailed documentation. So I have prepared for you some drawings that show each and every step in a very detailed way, and also some side views and sections. So the new Stair Tool allows you to both model in a very intuitive way and also to create professional level documentation. Now you may notice one more thing in this stair, which is that it is equipped with a custom railing. So this brings us to the second part of my presentation, which is creating railings. The railing in ARCHICAD 21 is a separate tool from the Stair Tool, because in order to give us more flexibility, because the railings tool is associative element, but it can associate. So it doesn't only associate to the stairs, but can also link to the hosting structures, such as the slabs. So it allows me to create the railing in a very intuitive way. You can see when I start making my railing that it can associate to both nodes and segments. So when I start making my railing here, just clicking on the bottom and the top of the stair, it will automatically detect all of the nodes and segments of the stair. So I can just continue, and I can detect the slab points as well. Continue building the rail on my next stair. Again, just finding the bottom and the top point will allow us to snap to all of the edges and the nodes. And just finish up this railing on the top of the slab. You can see how easy that was to create this railing here. And of course, this is in the schematic view. This railing and these stairs also have a very detailed view, and we can see that all of the accessories and bars and rails have been placed properly. So as I've said, the railing is an associative element. It will link to the host structure. So if I change the boundary of this stair, then the railing will follow the changes at the same time. This goes as well for the slab as well, obviously. So we can simply curve this corner, and then now we have a really nice double curve. And the railing will, as it is associated with both the slab and the stair, will follow these changes. Now, similarly to the Stair Tool, the railing is also an assembly element. We can specify our own rails, panels, and bars, and we can create our own pattern that will create the railing. So in this case, I've used a very simple example. It is just a glass railing, but of course, all of these settings can be saved as favorites. So I can easily apply one of these favorites and just change the stairs in a single click. Now, after these examples, let me show you some more detailed examples from all over the world to see how far we can go with the Stair Tool. Now, this is a quite typical example of a residential house in the United States. It's a wooden staircase, and at this kind of staircase, there's a very typical detail at the bottom of the stair. This is called the bullnose stair. I can show you very quickly what does that mean. So we can easily curve all of these steps and create that very special shape. There we go. So this is the typical bullnose stair. You can notice one more thing about this stair, that while it is one single element, we have specified two different types of structures. In the first flight and the landing, we have used the monolithic structure, but at the same time, we have used the traditional wooden structure for the last flight. I'm sure many of you have traveled in the subway before, and this looks very familiar to you. In these kind of stairs, it is a safety requirement to have some accessories such as a draining or a non-slip surface on the steps. So with the default ARCHICAD elements included in the Stair tool, we can go into such a detail and build these kind of stairs very easily. In this example, I'm going to show you a typical steel escape stair. These stairs are usually built with well-known steel profiles. So now it is possible to create these kind of structures with these steel profiles. So we can really create very realistic structures. Of course, if we change the profile along the design process, then all of these stairs will update at the same time. And I would also like to draw your attention to all of these details, which has all been created with default ARCHICAD elements. So the steps and the railings and all the structure is just the default stair elements in ARCHICAD. So we can go to all of this detail just using the default Stair tool. In my final example, I would like to show you again what kind of small details we can add to these stairs to make the structure more realistic and also to help the construction process. Of course, we need to fix the connection of the structure to the hosting slab by adding these steel plates. You can see that it goes down to very small details to be able to help us make the construction process much smoother. So this was only a preview of what the Stair tool can do. I'm really looking forward to see all the amazing designs from you. I hope now you can see how easy it is to create stairs in ARCHICAD 21. So Ákos, the floor is yours.
Thank you, Peter. I introduced the Stair tool as a design tool, but I think by now you might be convinced just as well as I am that if you want to go to the full extent, you can create one-to-one construction level detail stairs with this tool, or in US terminologies, LOD 500 as well. Also, I hope you could foresee the huge potential this technology could bring to other parts of BIM as well. But now we are talking about ARCHICAD 21. So let me play you a small video that we put together from very famous architectural classic stairs remodeled in ARCHICAD. The very reason we did this exercise is because we really wanted to challenge our new Stair tool. And we really wanted to see if there are any limits to that. But I can tell you we could achieve everything we wanted. So let me play the video for you now. Thank you. We are right now running the same challenge with the railing tool as well. So our colleagues back in Budapest are working on the Great Wall of China with the railing tool. So stay put for that. But with that, we have arrived to the third workflow we would like to cover in our today's presentation. And here we broaden up the scope and we include other disciplines into the workflow as well. Of course, architects have to work together with different disciplines using a whole array of different software solutions. ARCHICAD has always been very good at interoperability. I think it's not an exaggeration to state that ARCHICAD has the largest number of data interfaces to other applications, other BIM applications. Also, we are best in class in supporting IFC-based workflows. But interoperability or multidisciplinary work is not just a one-off step. It's more an iterative process or a workflow. So we would like to share with you now the latest and greatest enhancements to our OpenBIM workflow with ARCHICAD. For that, I would like to invite on stage my colleague Tibor Szolnoki.
Thank you. Thank you, Ákos. Hello, everyone. So let's see what's new in ARCHICAD 21 regarding OpenBIM. As Ákos mentioned, we have been a market leader in this area, but we made this solution even better in 21 and more fluent and more straightforward. And actually, there are three challenges or three areas that I would like to talk about OpenBIM. The first one is how we bring in data into ARCHICAD, how fast we can get IFC files into ARCHICAD as a reference model. And the second part is focusing on making collision detections between these reference models. And the third part of my presentation will be focusing on data management and data classification in ARCHICAD for export. So let's start with the very first step in IFC workflow, and this is how we bring in IFC models into ARCHICAD. And then the major challenge here is that we have to deal with large number of IFC files, and we have to deal with large number of different disciplines. And we saw that let's just do it in the most simple way, in the most straightforward way. And actually, we had a solution which we used with ARCHICAD files, and this was the hot link modules. So we have now a very similar solution using very similar principles for IFC files. So all you need to do is just go to Place Hot Link, and from the Place Hot Link interface, you can choose directly IFC files. So it couldn't be more simple than this. And as you can see, in this particular model, I'm working with a structural file, an MEP file, and a site model, all from the very same interface. After hot linking, we have great solution for visualizing these different discipline models in the context of the ARCHICAD model. With ARCHICAD 20, we introduced these graphic overrides, and I'm using these graphic overrides to show these structural elements in the context of ARCHICAD model. Or as another example, let me show you MEP model. And here I can just highlight one of the advantages of having these IFC hot links. For instance, these IFC elements can be selected with a single click. So it's much easier to work with them, or it's much easier to just delete them if you don't need them. But there is another challenge, and this is probably even more important than bringing in, is that the large number of updates required in these models. Every day you receive a new version of these IFC files from your consultant. So how fast can we update? This is the question. And again, the solution is using these hot link modules. And here, we can bring in the hot link module manager in a simple way as we use with ARCHICAD modules. And there, what you can do is just simply click on the IFC file that you would like to update or relink, and just click on update, and everything else is managed by the software. Okay, let's see how the updated MEP model looks like. This is how it is. It's much more detailed. There's more details added. And we were able to see the results of the changes with one single click. Okay, so that was the first part of the workflow, IFC hot linking. But what is the reason why we are dealing with these referenced IFC models? Why are we doing this? Of course, the reason is to find problems, to find issues. And the tool that we are needing for this is called collision detection. And actually, collision detection was available in ARCHICAD, but only using MEP Modeler, which was an extension to ARCHICAD, an add-on, or using external applications like Solibri. The great news in 21 is that collision detection became an integrated part of the software, and I would like to show you how you can work with this. And I will start with the most typical collision detection workflow, which is between architecture and MEP. And let me bring up this brand new collision interface, which is integrated into ARCHICAD now. Okay, so how does this work? Basically, you can create search criteria, and with these search criteria, you can define two groups between we would like to do this collision detection. So in the first one, I would like to put MEP elements. Actually, here I'm using a layer or layer combinations to find and identify those parts. For the structural elements, I'm defining them with the type of ARCHICAD tool that was used for modeling them. So walls, columns, slabs, beams, they are all those elements that are forming this architectural model. And once we made this search criteria right, we can just click on check. And due to the brand new engine, which is much faster than in MEP Modeler, we will see the result. Altogether, there are 65 collisions in this particular model, and we can bring up the markup tool where we can actually see them one by one, and we can actually make a decision what to do with them. But right now, I believe that there are too many issues, and the reason for these too many issues is that I'm not focusing on the real problems. I would like to focus my collision detection on finding problems between MEP systems and maybe one component of this building, and these are the footings. Okay, so how easily we can do this is due to this more intelligent search criteria in this collision detection. So here I will go for MEP, and on the bottom part, I will go for footing. Let's just take a closer look at this dialog. And as you can see, there is an option here to search for footing elements. Later on, I will talk about this, but what is important now that this intelligent classification-based search criteria is just much easier, much faster. So let's just do the check-in again. Altogether, there are 16 issues. And using this highlighting, I can easily identify those problems. I can understand that this water pipe is colliding with the footing system right here. What else can I do to make the communication right? All I need to do is just, I can add comments, or I can even save this camera position, and I can send it to my consultants as a BCF file. So this makes communication very straightforward, and this way we can communicate the issues in the context of the BIM model. Okay, so that was the second part of the Open BIM workflow, which was collision detection, integrated collision detection in ARCHICAD. But I guess you're already wondering how I was able to do this classification in ARCHICAD. And this is actually the third part of Open BIM, which I would like to talk about. And this is a brand new concept in ARCHICAD. So why do you need classification? Of course, the reason is to find elements properly, and also to be able to filter your models according to the need of the other parties, of the other receiving parties. So how we do it in ARCHICAD 21 is this brand new classification manager. This is a very easy to understand, very logical interface element in ARCHICAD 21. Basically, it is a tree hierarchy. It's a tree hierarchy that helps us to organize our building elements. Even if they're a very complex structure, we can arrange them in a logical manner. So for instance, I was talking about footing. I was using footing as an example. So footing is located under construction element category. And another thing that you can see here, that with these classifications, we also associate parameters, properties. If you have seen the ARCHICAD 20 demonstration a year ago, you have noticed that in 20 we introduced the concept of properties. This is basically metadata associated with elements. And with classification, we can associate these properties automatically to the building components. Now, the classification system that you can see right here is the default one from GRAPHISOFT. It's the native ARCHICAD classification system. But later on, I will show you that you can create your own classification system. You can create custom ones and according to the actual requirement. So using this classification system, you can do many things. One of the things that is a great productivity feature that in the Find and Select dialog, you can use this classification to identify elements or find elements. So instead of just going one by ARCHICAD element types, I can just use classification and click, and then instantly you will be able to select all these footings. Now, the reason why I'm using this example, because that particular footing model is using different ARCHICAD tools. There are some beams, there are columns, even morphs here. But no matter which tool you have used for modeling, using the classification, you can easily find them. By the way, classification is now an integrated part of the ARCHICAD tool dialogs. They're located right here, and that's where you can associate this classification information with ARCHICAD components. Okay, you have already seen classification working for Find and Select, for collision detection, but there is another area which it can help us to be more productive, and this is interactive schedules, quantity takeoffs. So in this example, I would like to calculate the volume of concrete required to model the footing. And as you can see on the left side, this particular model is composed of beams, columns, morphs, and walls. However, the search criteria or the interactive schedule criteria is pretty simple. It is basically one element, ARCHICAD classification footing. So that's how easily you can do complex interactive schedules using simple search terms with classification. Now, one more thing about classification, which is very important. In certain parts of the world, there are already standards in place, standards in practice for the organization of building elements. And these standards are now natively supported in ARCHICAD. And let me show you how it works. From the classification manager, you can directly access to a website, which is managed by GRAPHISOFT. And on this website, we have listed the most significant, most frequently used global and local classification systems. Let me just mention 4 of these systems: Uniclass and NBS. NBS stands for National Building Standard in the UK. These are highly, very frequently used classifications over there. And from the US, I would like to mention Master Format and OmniClass. So all these are available on this website. You can just click here, download, and after downloading these XML files, you can integrate them, you can add them to your running projects. How you can do it is pretty simple. Just click here, and there you go. Master Format is now also available in this particular project. That is also an example that, according to the receiving party, you may have to classify your elements differently. and ARCHICAD 21 supports this. You can have as many classification systems as you wish. Okay, so this was OpenBIM. That was the first part of my presentation, but there's actually much more in ARCHICAD 21. There are lots of productivity features. Actually, there are so many productivity boosters in this new version that I'm not able to show you all of them. Instead of that, I just want to give you some highlights, some of those productivity features that are requested by many customers. And I would like to start with a very popular ARCHICAD feature, which is there in the ARCHICAD for a very long time. I couldn't even remember when it was introduced to ARCHICAD. So this is the parameter transfer. I think you're all familiar with this concept, the pipette and the syringe, right? I guess you use it every day. It's a very loved feature. And with this, what you can do, you can transfer all the settings of one element to another one. However, in certain scenarios, you need to transfer only part of these parameters, not everything. With 21, this is possible. So for instance, now I would like to transfer all the geometrical parameters of this door to that door without changing its ID. How is that possible? Actually, it's very simple. Just pick up the parameters as we used to. And when I inject, before the inject operation, there is this on-screen helper, which offers me different options. For example, I can exclude the ID and the layer from this parameter transfer. And then, like magic, let me just pick up again. Pick. And exclude ID, and ta-dam. So as you can see, the ID is intact, but all the geometrical parameters has been transferred. This is fully customizable, so you can really set your preferences, and it's a great way to maintain the consistency of your project. Now let me continue with a seemingly minor issue, but this is very important for the architects because they're very picky on the quality of documentation. So this is a site plan, and with this dashed line, I'm showing the contours of the building to be built. Now, to be able to understand the challenge or the issue, I go closer and I turn on the bold line representation. So what is the problem? What could be the problem here? Of course, the corners, right? The corners are not connecting properly, and architects, they want to see these corners properly made, especially on the printed documentation. This is extremely important. Now, in 21, we have a great new algorithm with which we can help to fix this connection. So I just click here, and this more natural solution cleans up all the corners, and you can be sure that your documentation looks just right. Okay, next one. This particular part of this demonstration was purposely made for this Japanese audience here, because this is one of the long-standing requests of our Japanese customers. What is this about? Okay, this is about dimensioning composite walls or composite systems. We could, of course, assign automatic dimensions to walls, but there was a special request from our Japanese customers to be able to show core faces and reference lines out of the box. Of course, you could do it manually, but this is just more faster and automatic, and it's a great time saver. So now, if I just select this wall, you can see that this is the reference line, and all these parts of the wall can be dimensioned automatically. And of course, this is fully associated with the given element, a building element type. So if I just change to a different type of wall, or if I change the location of the reference line, it updates automatically. Right. Oh, there's some applause over there. Okay, I'm happy that you're happy. And Let's just continue. I was talking about data all the time with the classification, and the importance of data is just getting more in the focus of BIM industry. But it's also very important how we can visualize the data. And labels are just a great tools for that. Now, in 21, we could go even further with these Autotext labels. Let me just show you what I mean. So these labels are now supporting access to many parameters. For instance, I was talking about this classification. So let's just add classification as an auto text, or maybe let's just add some properties. For instance, I would like to show the actual technology used to create this column. So, of course, the list is very long, and you can choose your own preferred parameters. What is important that it's graphical, it's visual. There's no need for any GDL scripting. It is available out of the box for any users. And OK, let's not add more. I just need all these three. And of course, this can be picked up, and it can be applied to other building elements as well, like these walls. OK, let's continue, because I have many other features to be shown. And let's talk about documentation. Of course, architects would like to focus more on the design and less on doing repetitive work. And a typical issue is that you have large number of drawings, especially you have large number of sections and elevations in a complex project. And to make these sections elevations right, you need to set the boundaries properly according to the paper size. And you could do it in ARCHICAD 20 and previous versions as well, but you have to switch between floor plan and 3D to just to adjust these boundaries. Now we can do it in a more straightforward way, right here in the section view. I just grab these boundary line sliders like this, maybe like this. Maybe I would like to show upper parts of the building with the antenna, or I would like to just go deeper in the ground to show the garage. So it's all visual, it's all graphical, it's very natural. So this is the real ARCHICAD way of working with documentation. And we have seen great modeling solution from Peter with the brand new railing and stair tool. But let me just give you some other modeling productivity boosters from 21. So the challenge here is that I have this walkway in the garden, and I have this garden lamp right here. What I would like to do is create multiple copies of this lamp so that it follows the curvature of this walkway. Okay, so that's the challenge. What is the tool that I can use for this? Of course, we have multiply tool for a long time. This is really a great tool, but in 21, it became even more powerful with the addition of this rotate to path option. What it does is that it helps you to automatically pick up a path or a contour, and then with the next click, you can just define the starting point. And also, very typical ARCHICAD solution is this great graphical feedback, which helps you to identify the numbers of elements created. And let me just draw your attention that all these lamps are following the curvature very smoothly, very nicely. OK, thank you. Or maybe another example of using multiply tool. It's a slightly different example, because in this case, I would like to arrange elements in an organic manner. So there are no strict rules. It should be very organic, very natural. I would like to create something like a forest here. So what I will do is I just pick up these trees. Okay, and again, using the multiply tool, I'm using a new option. It's called randomize. Again, I will start with picking up the contours of this green area, and then with the next click, oh, this is going to be a very dense forest. Well, it's actually nice. So this is how fast you can create these organic shapes. Okay. Last but not least, let's just talk about the organization of your projects. And actually, ARCHICAD has a great tool for that. This is called the view sets. So with the view sets, you can define predefined representation of your BIM model, floor plan, section, elevations, and 3D. And what I'm focusing now are the 3D views, because here we had actually a shortcoming of ARCHICAD. Some of the 3D related settings were not saved or were not saved with a name with the view sets. Let me just explain what I mean. I have a couple of 3D views. I have this representation, I have the other side of the building, maybe this top view, and even this cutaway view. These views are quite okay, but I would like to make them more natural. I would like to have contour lines, I would like to see the shadows and the sky, and I would like to apply these settings to all these views at the same time. How can I do that? Well, now in 21, using the view settings, in the view setting dialog, there is a new concept or a new parameter, actually, and this is called the 3D style. Okay, that's the name, 3D style, where you can find presets with a given name. You can create these presets yourself. I'm going for OpenGL shading, contours, and shadows. And then it will be applied not just for this particular 3D model or 3D view, but all the other views as well. So this is a great way to organize your view sets and being more consistent even with very large and complex projects. Behind this, there is actually a new dialog, which is called 3D styles. And basically, this controls the 3D engine, the background, the contours, the shadows. So everything that is needed to make the 3D right is associated with this setting. So this was my short presentation about some of the productivity features and OpenBIM. There's much more. I hope you will be able to enjoy it yourself. And now I would like to give the word back to Ákos. Thank you.
Thank you, Tibor. With this, we have arrived to the very last phase in the AEC workflow, just as well our demonstration today. And at this phase, I think BIM is considered more or less a database. And a database is of no worth if you cannot access the data put into that. So there is an abundance of data in the BIM model by that phase. And we would like to provide access or workflows to all the people in the AEC process. These people, more often than not, are not proficient in BIM. In some cases, they don't even have a computer, just a mobile device. So what can we do about them? Of course, if we offer the appropriate workflows to cater for their needs, then we are doing good for them as well. So here you can see a slide about all the different stakeholders in this phase of the process. And I would like to just highlight 3 different workflows, so steps we would like to cover in the demo today. The first one is, of course, at the core of this whole thing is how you can provide access to any people with any device in any location. So first one is about sharing, data sharing. The second one is about how you can utilize your data once you are holding that on your device. Of course, you cannot exist in isolation, so you have to be able to have workflows to connect your BIM database with external information sitting in external databases. So our second step here is referencing. And a third step is about a layer that's mission critical in any workflows, which is communication. So you have to be able to also deal with the other parties, your peers, when you deal with data. So these are just 3 examples of many that we will show you today in our last example. So let me invite Peter Trom on stage to do the demo.
Thank you, Ákos. Hello everyone. 日本の皆さん、こんにちは。本日はいつもと違って英語でのプレゼンテーションになりますけれども、よろしくお願いします。So, I believe all of us agree that BIMx is a tool that is loved by everyone. But to use it, first of all, we need to have our hypermodel on our mobile device. The life of the project starts in ARCHICAD, and once you are ready with the design, then you can save a hypermodel locally on your computer. Then you need to transfer it to your device. There are multiple ways of doing this. First, you can simply connect your tablet to your computer and drag and drop the file. Or you can use any cloud-based storage services. You simply upload your file, and from BIMx, you can have direct access to these storages. It can be iCloud, Dropbox, OneDrive, Google Drive, or any other solution. You can choose your favorite one. So transferring to your own device is pretty straightforward. But now let's imagine that you are on the construction site, you are discussing some issues with the construction manager, and he suddenly asks you to send him over your hypermodel to his tablet. Then wouldn't it be great if we could simply share it with him directly from our mobile device? Well, the good news is that we can do this because BIMx fully supports the airdrop function of the operating system. It will immediately detect the available devices nearby, and with a single tap, you can transfer your model. Of course, it's needless to say that there is a very similar solution on Android platform as well for this. So these file-based model transfer methods perfectly support the workflow of a one-time data exchange. But it doesn't fully support the situations when there is multiple iteration is needed. GRAPHISOFT realized this problem many years ago and developed the BIMx model transfer service. This service can be accessed directly from the BIMx application, and it is optimized for speed, and it has been optimized to support workflows with multiple iterations. So once you have uploaded your file here, then from the second time, if there is a change, you can upload only the modified parts of your model. So if there is only a single layout affected by the change, then only that particular layout will be uploaded. Once your model has been uploaded, it will be listed among the public projects. So everybody who visits this site will be able to see these projects. They can check some details about it, and if they like it, they can download it to their mobile devices. But in many cases, of course, it is not really feasible to share your project with the whole world publicly. For this, GRAPHISOFT SSA customers have the benefit to use a private storage space on the BIMx transfer service. To use this storage space, they will need to log in with their GRAPHISOFT IDs and with their password. Once we are logged in, then we will be able to see all our private projects. We can even organize them into folders, and in addition to this, we can set the visibility of each hypermodel individually. You can set it to private, which means that only those have access to this file who have a direct link to it. Or you can even further increase the security of your file by making it password protected. So those who have this access information can access your hypermodels, and with a single tap, they can download it to their mobile devices. But what happens if you change something in your file and you updated your hypermodel? How will they know that there is an update available? It is simple, because BIMx model transfer site generates push notifications. So, as you can see, a standard push notification badge will appear on the BIMx icon. When you open the application, it will show you which model has an update available. You can even check some details about the update, and with a single tap, you can download the modified parts to your mobile device. So with this, you can ensure that everybody has the up-to-date version of your hypermodel. But I'm pretty sure that you also want to make everybody to know that you designed this building and you are the owner of the intellectual property. So let me introduce the new Architect's Credits feature for this. Architect's Credits will show up when you open the 3D model in your hypermodel. And once the model has been loaded, it will be minimized to the top right corner of the screen. But with a single tap, you can maximize it anytime. You can customize the content during the publishing process from ARCHICAD. You can add the custom image, and you can even add a link to your website, so everybody can easily contact you if they want a similar or an even better design. Okay, so we distributed the model. Now let's do some real production work with this. If you recall Apple's marketing communication, you can see that they target professional customers with their hardware devices, such as this iPad Pro or the Apple Pencil, and with their software solutions, such as the recently released split screen function. Last year, we showed you a professional use case of BIMx. We connected it to a facility management database, and we used it to visualize and highlight elements from this database. But we had to go back and forth between the applications, so it was not perfectly comfortable. So wouldn't it be great if we could see those two applications very next to each other? Well, the good news is that we can do this because BIMx now fully supports the split screen function of the operating system. So let me open my browser next to my BIMx, and let me just log in to the facility management system, because I would like to check my tasks for today. Once I'm logged in, I will have a list of my to-dos for today. Let me just try to enter my very professional password one more time. Maybe it will work for the second time. And yes. So here I have my maintenance planning section. And here I will be able to see my tasks for today. I will need to make some maintenance work on some fan coil units. If you remember, last year we did the same thing, and we used BIMx to identify the location of these units inside the model. It was very nice, but we had to do it one by one, and that was not that efficient. But this year I'm using the latest version of BIMx with the multi-element hyperlink feature. And with this, I could create a task for myself that contains all fan coil units I need to check today. So let me show you what happens if I tap this. It will immediately open the most relevant view in ARCHICAD. In BIMx, of course. And it will highlight all fan coil units I need to check today. So with this, I will be able to optimize my routes in the building, and I can finish my work very efficiently. So BIMx made my life much, much easier. Of course, I'm not working alone. We are a facility management company, and I have colleagues using ARCHICAD in our office. I have some other colleagues using BIMx on their iPads in the building. We have a company, BIMcloud, and we are all joined to the very same project, so we can send BIMcloud messages to each other. But how will I know that I have received a new message when I'm not using BIMx? It is simple, because similarly to the BIMx transfer site, all messages coming through the BIMcloud will generate a push notification. So I can open my application, and if I go to the list of my messages, I will be able to see all incoming messages in the context of my hyper model. And it looks like I have just received a message which hasn't arrived yet from my colleague Annika, and I know that she's saying, Peter, please go to the ground floor and check some fan coil units. Oh, here it is, because it is malfunctioning. So with the integrated teamwork messaging and the push notifications, I was able to react to urgent issues like this immediately. Now, in my final part of my presentation, let me be the client. So I am the client who has just received the latest design from the architect. And to be honest, I really, really love the design. And BIMx is all about sharing. So wouldn't it be nice if I could share this experience with my friends and family directly from my BIMx application? Well, the good news again is that I have a good solution for this, the new direct Facebook update function of BIMx. If I tap Share, I tap Facebook, it will immediately do everything for me. I can even enter a message. Prepare for the housewarming party. Yeah. And post it. It has been posted. Now let me show you how it looks like in Facebook. I open my Facebook application, and here we go. It is already there in my timeline. And when I tap it, I can look up, I can look down, or I can look around. As you can see, it gives the very same experience to everybody as what I had in my BIMx application. So I believe this is a really, really cool feature. So let me like it. No, I don't just like it, but I love it. Thank you very much.
Thank you, Peter. So with this, we have arrived to the end of our demonstration, almost. Because in some famous demos, there are always one more thing. And I have one more thing for you today as well. So we consider BIMx a very strategic platform for us. But there is an Achilles heel of any workflows involving mobile devices. And this is the relatively weak hardware on these devices. But I can tell you that Graphisoft has always been very good at solving these kinds of problems. So high-performing software to low-spec hardware. So we are running a research project that we are very excited about. So this is not in ARCHICAD 21, but I still would like to show you live a prototype that allows us to deal with virtually any size of building models on mobile devices. So let me fire up my special BIMx. Which is my BIMx lab. And this is going to be a very short demo. We have tons of gigantic projects in our lab, but for the demo, I wanted to brought here our own campus back in Budapest. This is good for the demo too. So you can see this is the whole campus here. It's under development. We call it the Hungarian Silicon Valley or the Little Silicon Valley. And for the current commercial version of BIMx, the hardware limit would be just one building on this whole park. So let's say the GRAPHISOFT complex with all the disciplines together, pipes, systems, would be a practical limit to be able to use on BIMx here. But with the new version, we don't have this limit at all. So actually, the whole park or even the whole Budapest would not put any big issue for this app here, but just for the sake of fun and for our own way of boosting polygon counts in the app, I would like to show the underwater world here. Or if I go, navigation is not perfect in this version yet, but you can see that there is a submarine, or if I go up then and look to the right, and I should be able to see a TIE fighter fully detailed. And so we could put here anything. And now comes the serious part of the demo. So what makes it happen? Normal applications load in the entire model data so that navigation is smooth and fast. Of course, it puts a true practical limit to the model size can be loaded into memory. But here, if I look around, please watch how it's on the fly built up. All the time, it's not just built up, but streamed in to the memory, the model, and that makes it possible for us to practically deal with any size of data. So this is a research project, not really released right now, but I really was excited and eager to share it with you. So for now, I would like to ask back my PowerPoint because we would like to wrap up. And here I would put up one more time our 4 workflows that we have covered today. And as a close-up, I would like to play a video for you. We have modeled ARCHICAD 21's signature project so that we can see if it can be really modeled. And I would like to play this animation for you now. The lucky situation is that the designer, the architect of this building is in this very auditorium, and you will be able to hear from him in person tomorrow. So let me play the video, and thank you for your attention.